tiny raisins in it. And that was our bias and our prejudice based on what we saw, that everything should centralize around us. And I'm saying now we should open our eyes and our brain to see the magnitude of what lays in front of us. Space travel will become a reality. Our children growing up will have an excitement and a universe to travel into, but the values of the human race has to change with that.
While Joe Newman is still fighting for recognition and just compensation, many entrepreneurs are racing to be the first into the marketplace with magnetic motors that are built with high-tech space-age materials and employ microprocessors to regulate pulsations and RPM. David Porter of Galtech Semiconductors demonstrates his recently patented permanent magnet motor called the carousel electric generator.
This is the latest version of the carousel motor generator. It's a rotary version. Rotary inside. There's 18 separate sections, what we call a coil section in here. 18 make up the outer diameter. There's 6 coils here that we're using to drive the motor. At the top here we have an encoder which sends a pulse down to the electronics and basically lets the electronics know where the rotor, the rotating part here, is in relationship to the coils and tells the coils when to turn on and off. That's done by a specific index point that the encoder has that sets the relationship between the two. And the electronics down here in the box is basically a set of TTL logic counters. It counts the number of pulses from the encoder, and it turns the power on and off to different coils depending on where the rotor is at the time. We have also hooked up to this system a connection to the computer over here. What it gives us the opportunity to do is change the duty cycle on the system. We can change it from a pulse rate of 1 pulse per cycle up to 40 pulses per cycle, which would be 100% duty cycle. That is incorporated in, and what we do is change the pulse rate on the computer. It downloads the data to the electronics. When the index pulse comes around, which comes around once per revolution, it updates the data in the counters, and that's what changes the pulse rate on the system. Okay, we don't have an automatic start on the system right now. That's something that the Intel chip will do. We'll start it up at a pulse rate of approximately 13 pulses, which gives us a 16% duty cycle. It takes a while to spool up because, like I say, it works also as its own flywheel, so we build up the power gradually. The thing about this system is that everything floats on the magnetic field in there. You have very little internal friction. Once the system gets up to speed, it stabilizes at a certain RPM. Right now we're running at about a 30% duty cycle per channel. The speed is still coming up a little bit. Calculate the speed off of the scope here, and we're running about 1,850 RPM. This white and the green shows the 2 channels on the motor. The little spikes there are the amount of time that each channel is on, and the flat part at the bottom is the amount that it's off. So you can see how much is pulsing and how much time it's off and how much time it's on. One of the analogies we like to use is it's like if you pick someone up and take them across the street, you use a lot of energy. You put them in a tire, once you get it started, all you got to do is tap it a little bit. And so you use a lot less energy to move the same load. And that's what we do. We build it up to a high speed, and then we just tap it with a little juice as it goes around. And we use the inertia built into the system to take it the rest of the way there. So we're using a high-speed pulse on the system. What we're doing is removing the energy from the magnet. The magnet has a specific life. They lose approximately 1% a year. So we're not actually trying to create energy from nothing. The system will not run forever. It's not perpetual motion. We use the amount of energy that is in the magnets. Once that energy is used up, the magnets can be taken out, they can be recharged. All we're doing is maximizing the efficiency of the electromagnetic flux density that's there to the production of electrical output.
When will we be able to see free energy devices powering consumer products like this electric car? Well, they're already here, and you may be able to purchase one by the time you see this program.
In Oklahoma, where oil has been king for over a century, inventor Troy Reed has been busy in his shop constructing rotating magnetic motors that he believes will soon revolutionize how we get around.
And it does work. This is a new prototype of the magnetic motor, and if I can explain a little bit about what you call a magnetic field. All magnets, the big old wooden prototype, has a system. As the motor went over, it had a tension to jerk over like that. If you take this motor here and you take your finger and rotate it, it doesn't have that jerking in it. So what I've done, I got rid of the crankshaft. I've got rid of the injectors, and the system in this motor here, as you crank this motor up, and like you do the other one, the motor will start running, and what I'll do, I'll energize it on this motor here. If you can see these amp gauges over here, this will come, when we get it up to about 150 volts, we'll unplug it and we'll turn the light on. If you turn this around where you can see this side here, all the working parts is behind this system here, operates from a little computer. Takes just 5 volts. It's 150 volts. What we're going to do, turn off all the switches, make sure there ain't nothing plugged into it. There's the plug. There's your 110 volts. Motor still running. You can operate this table plumb around. Still got energy running. Nothing tied up in the back of it. Nothing on the floor. Rotate around, still running electricity. So we're looking, hoping this time next year that you'll be able to use it in your home. So that's another. And what's good about this, you're talking about electric automobiles. This car, this right here can set it in the back of an electric automobile and generate electricity and charge batteries up in a car. Beautiful automobile. You can drive it anywhere you want to. You don't pollute the air. All the other electric automobiles that I've actually seen has been nothing but just standard transmission. This is an automatic transmission car. There's not a whole lot of what you call junk, I would call, under cars. I've seen a lot of electric cars that had a lot of stuff in it. The only thing that this has a battery to run the radio, the blower. We've got 2 safety switches over here that can be mounted into an enclosed system, but we did this where you could see, where people can see this car with the technology. It's a safety switch system. This is a controller box, a Curtis control box. It cuts the amperage down. So with the amperage, here's what's real good about electric automobiles. All electric automobiles that has surge technology with this in it, they create heat. They've got to have a fan to blow this Curtis controller off because it gets hot. We don't want that to get hot. We want to stay that cold, because once it stays cold, you save on all the computer chips that's in this controller. So that means you can go farther, longer, and you won't have no problem.